here, but don't close down. We have one more, after this, we have one more really major unit to do. It's really like the crux of your whole statistics course. All right, so you needed to find your critical values. Remember, a little different. This is going to go from 0 to infinity. So it's always going to be positive. You're going to have shading. But the shading on this is different. Well, the area is different. It's always area to the right on this, which I don't want you to worry about. So therefore, ladies, you're going to do it the same way we always did the other one. You're going to do 1 minus 0.99 divided by 2. This is going to give you this number. Your table 6 is symmetric. Or you can subtract this from 1. They got to add up to 1. The area under the curve always adds up to 1. These are the two numbers you're going to look up on the headings. Then you're going to use your degrees of freedom, because that's what your table 6 says, degrees of freedom, and come down the row. So these are your numbers. You get a large one and a small one. Because your number line goes 0 to infinity, your left one is the small one, the least of them, the lesser. Your right one is the greater one. And that's how you tell. Don't get hung up on the area is backwards. Yeah, the area is backwards. But all I need you to do is this part to come out with these two numbers. I want to keep this the exact same that we always do. 1 minus 0.99 divided by 2. There's no inverse norm for this. There's no calculator step for this. This guy, same thing. 1 minus 0.98 divided by 2. This is going to give you 0.01. Subtract it from 1. These are the headers that you're looking for. Degrees of freedom, 25. Pull out your two numbers. The smaller one goes on the left. The larger one goes on the right. Everybody okay with that? Anybody not okay? Because you're going to have to be able to do this. Okay. Again, there's another one. This is like the most important part of this whole thing, because the formula is really the only thing you have to think about. Again, 1 minus 0.80 divided by 2. I got a 0.10 and a 0.90. My degrees of freedom is 50. I come down my chart, I find those two numbers. The left one is the less one, the smaller one. The right one is the greater one, which totally makes sense because my number line goes like this, from 0 to infinity. There are no negatives on this. It's like you're only dealing with quadrant 1 of your axes. Then I had you use this. These are the two values that you're finding. This is your degrees of freedom, and this can be one of two things. If it is a sample, standard, and they'll both be from your sample. If it is a sample standard deviation, then you're going to put it in and square it. If it is a variance from your sample, then you're just going to put that in by itself and not square anything because it's already squared. So sometimes the problem will give you a variance, which means your standard deviation was squared. Just put that in. If they give you a standard deviation, which is why I was telling you guys over there, when you do your Calc L1, you get an SF, SX. Just put that value in here and square it. Don't bother doing it in your calculator first, because then you got to transfer it over to this. So again, you're going to do the 1 minus 0.95 divided by 2. I'm going to get 0.025 and 0.975. I'm going to look up my two values with my degrees of freedom. And this is my left one, my lesser one. This is my right one, my greater one. Your formula needs them reversed because the right one, which is greater, if you divide by a larger number, you get a smaller answer. It builds your inequality statement. If you find you reverse them by accident, you're going to notice it on your inequality and just flip the inequality. Don't switch the sign on it. Just switch those two numbers to make it a valid inequality. Don't leave it to me with the signs switched, because technically that's wrong. Because Common Core lets us do that, but I totally disagree with that. Because you read your numbers left to right. They should flow. Again, build this, then take the square root of everything. This is your confidence interval for your variance. This is your confidence interval for your standard deviation. Again, there's no calculator step for this. But I'll give you the formula, and then you'll do it. Now, notice in this, they said s squared. What does s squared represent? Variance. Right? When I take the standard deviation and I square it, isn't that my variance? So you see where this s squared is? All you got to do is replace s squared with 11. Oh, sorry, 11.56. Do not square it again, because it's already squared for you. This is the only tricky part of the formula. If s is not squared, your formula is going to square it. If s is squared, your formula, do not square it again. Everybody got that part? John?
So at the end, you want us to round it 3 decimal places?
Um,
I did 2 because that's the one with the problem.
2, that's fine because your standard deviation is 2. I happen to be a 3 decimal place rounder.
I still don't know.
I guess my pre-calc carries over to me, but 2 is fine as long as your rounding is correct. I wanted at least 2, at least whatever your standard deviation is. It kind of makes a little bit more sense if we do that, because that's your point estimate right there. So this way your boundary will be within that same book as that one. Any questions on this? This is a trickier one because they gave us a variance, not a standard deviation. Okay, you're going to put this in your L1. You're going to find your sample standard deviation. We find x bar. This is our mean for our sample. We don't need the mean in this case. We need to look a little further down to where it says SS. You do not want the population one. You want the sample standard deviation. There's not a lot to get out of this. It's basically your standard deviation. That's all you're pulling out. Because it's a standard deviation, we are going to take care of this and square it right here. You do not have to go to your calculator to your var thing and square it there. Square it in your formula. Again, you still have to find your 1 minus 0.90, divide by 2. You got a 0.10 divided by 2, a 0.05, and a 0.95. Find your 2 critical values. The left one is smaller, the right one is larger. But in your formulas, they go the one on the right has to be the first one to make it smaller. Look how tiny those numbers are. And your calculator probably gave it to you with a scientific notation number. Make sure you don't leave me the e's in there. Move your decimals. That's how tiny this is. Did they say what this was? Yeah, that's okay. Maybe to check. But I didn't just to see what that was. Because the answers are so small. Yeah, thank you. This is the measurement of cough syrup. That's why these numbers are so small. And that's why we use a standard deviation or a variance for this, because the difference is so small in this. If we used your sample mean with a plus or minus your standard deviation, it would hardly be any difference. So that's when they measure this. If it's anything medical, you want to make sure you're getting the proper amount. You don't want to give somebody more than they need or less than they need. So anything medical, you're going to find it in here. Manufacturing, you're going to find it in here. Like even cereal boxes, cereal boxes vary in their weights. They're never measured exactly. And if they put too much in, then the manufacturer loses money. If they put too little in, then the consumer loses money. So they got to find a nice medium, happy medium. Okay, a magazine report. Whoops. A report includes the prices of digital cameras. Even though these standard deviations are higher, they still went with the standard deviation. They took 11 randomly selected digital cameras. They took the sample standard deviation. They used an 80%. They didn't need to be that confident. 80%? Give me a ballpark. No. So you're looking up the two values. You're plugging them in. They have a sample standard deviation. This is your S. This goes in here. Therefore, it's the standard deviation. We have to square it. Your variance probably means very little to you. Like, where's my variance coming from? My standard deviation makes more sense. How much your prices will vary. The variance, squaring that, it's not really that important for you guys. It will be in the manufacturing area. Like, I wouldn't have done a standard deviation one on this at all. I would have done a mean one, but whatever they decide to do, just to show you that it could be larger numbers as well. Everybody get this? And 19 that we either couldn't do or didn't have time to do, kind of had the same thing. You're testing water qualities for the hardness. Okay, your standard deviation is 15. So since that's your standard deviation, you're going to square it. You're going to do the 1 minus 0.95 divided by 2, find your two values, and plug it in. If you want, since the standard deviation is whole numbers, if you want to round this to whole numbers, probably looks a little bit better. Whichever you do, make sure your rounding is correct. Make sure I see the rounding. Just don't round less than your standard deviation place values. If your standard deviation has 1 decimal, I expect your answer with 1 decimal in it. If you give me 2, 3, 5, I'm okay with that. But it's got to have at least 1. Whatever your standard deviation has. Any questions on this? No? Okay. That 6.3 did the proportions. It started to make a point estimate using this. It was pretty simple. It has a 1 proportion Z interval if you're using your calculator. And we had a margin of error formula. Let me just look this back up. Oh, this is the other one. That was the end. So this is your interval, if you forget. And we had one more that had the n equation in there when you're finding your sample size. So look up that equation too. I want you to do this as a review. Okay? These numbers. You'll get a couple of, probably more from the 6.3, just because that was from before the break. So, write these numbers down. You have all this period. Make sure you do these pages. You wouldn't find any on the other one. Don't ask me why I got those. And it's just a couple from each. I think these are all the proportions, and those might be the other part. The proportions are probably the ones you might have to review. Look, I hooked these together, and I did that before the break because that was, go ahead. Yeah, because that really wasn't a real difficult part. That, unfortunately, I have a couple of thread paper. Okay. All right, so please write these down.